Okay, we're on the last major bit, I suppose, for the shader code, and then we can actually start playing with things. Sorry for sounding so demoralised. I've been doing these since Tuesday, and you can see how much time I've been putting in. Some of these videos I've had to restart as well. So, okay, so here we go. We want version 460, I guess. I don't actually know what version it's on. Core profile, and we want void main, and oops, wrong thing. That is going to be the basis of both the shader.ver and the shader.frag. But let's double check that quickly. GLSR or shader versions or version. See what version it's on. I thought it's on the same thing. Yeah, it's on 4.6. It's updated June last year. Well, okay, so that's right. Let's have a look. GLSR shader. See what we can find. Sandbox gallery. That's kind of cool. I wonder what's in. What we can pick from here. These look like they're WebGL though. Maybe they're not. They don't look exactly like WebGL. Usually, oh, that flash then. Sorry. Tell you what, I'll stop looking at that. What we're going to be doing, in fact, we can use part of this. So we want. You can see there's uniform variables in there. That makes me think the code is somewhere else as well, because uniform variables you usually pass into the shader. No, not pass into, but they're usually called. I'll tell you what, I'll explain it in better detail in a moment. So, what we're going to copy from here, we're going to copy the frag color because that's one of the main things of GLSL. That's in the fragment shader. But that's about it. There isn't anything else that's really copied. So we'll just close it off. I'll stop looking at that. What else we got? We can look at for shader stuff. Not a lot, it seems. Let's see what happens when you search write GLSL. Oh look, we got Learn OpenGL. That's that really great website we were looking at before. I really recommend looking at it. Okay, so this is we'll copy part of this. This is for the vertex shader. Oh look, it even says it there. This is exactly what we're going to do really. So yeah, we'll go on to vertex shader. So the first one we want is layout location equals 0 in vec3 pos. What is this? So layout location equals 0. Do you remember when we were writing in the object drawer? Let's open that up. Oh, didn't want to do that. So we're on the shader.ver. When we're doing the object drawer, we had this part here, bind the attribute pointer, or the vertex attribute pointer, location 0. That's what layout location 0 is. We could always make different ones and other ones and stuff. Another thing that we've got, which is unique to our project, is a uniform variable. We've got uniform vec. Let's make it vector 4 model, and this is what we did in the shader. So we haven't got a getter for that yet, actually. So we'll have to write that. But here we go. Uniform model equals get uniform location shader model. Okay. So quickly in this shader.h, we're going to have underneath here. We might as well make this a pragma region for future reference. Pragma region. Oh, I think is it just pragma region? No, it's pragma region like that. Getters. We could actually just call it uniform getters because this is going to be a big thing when we've got many uniforms. So we want gl un get uniform model, and just return uniform model. We're going to need that in a bit. And underneath here we'll just pragma end region. So we can just in future, we'll just be able to open and close it because it can get very long, and it just becomes very messy in my opinion. So shader that we've got the uniform model there. So GL position equals we want the model times the vector 4 of position. Okay, I don't know if this is going to make much sense to you. So GL position is the position in 3D space where the vertex is going to be, and we've got the model there, which is a uniform variable, which I'll explain in a bit, which basically times in the position of the vertex by the model position, which is what we're going to make in a minute. And that is mostly it, actually. What I was thinking about doing as well, quickly, was making another vec4. I'll make it vector 3. Actually, we'll do that in a minute. Let's go to the shader.frag. And so we don't have anything in here, actually. We're just going to have, I think it's frag color. Let's have a look at the website. What does it say? Oh, look, they've got vertex color there. And they've got an out vec4 frag color there. Let's make that one an R1 then, just to be sure. Out vec4 frag color, and then frag color equals, what should we make it? Vec4. I thought about changing. Let's make it like, so we got red first. Let's make it 0.5 red, nothing green, and then a tiny bit blue, and then alpha on the end. Okay, so red, green, blue, alpha. If we're lucky, this will just work straight away. I haven't really thought about what we're going to write in here. Like most of this series, actually, it's all just random. Now we've got failed to compile vertex shader. What's interesting is it says an error for the because we are not resetting the in the shader part here after we've called for the fragment shader IV. Well, before that, actually, we haven't reset this. So we'll reset result to 0 here, because if result equals 1, then we pass in the log anyway and rewrite it, so it should be fine. I don't think we're going to need to reinitialize the log file. But what that was saying was that GL position isn't a function, and I think it's because I missed off the P there. That little error there. Failed to compile fragment shader this time. GL position is not accessible. What? Is that because I initialized the thing at 0? Oh, screw it. We'll take this out. Is not accessible in this profile. Is GL position changed? No. It's because these are version 3.330. GLSL 4.6 GL position. Is it in there? Vec4 GL position. Have I just typed it wrong? Shader.frag. No. Vertex. GL position equals. Off topic. Looks like you tried to load the fragment shader as the vertex shader and vice versa. GL fragment shader, GL vertex shader. Okay. Vertex shader is a shader.vert. Fragment shader is a shader.frag. We're passing in the vertex shader, then a fragment shader. Vertex shader location, vertex string, fragment. Vertex code equals vertex. Yeah, fragment code equals fragment. So we're compiling vertex code there, vertex shader, fragment code. I think the fragment code wasn't passed into the fragment shader. There. Wow. This should work now, surely. Oh, we're getting nothing drawn. Very good, very good. Let's see what's happening this time. It's because I'm not using the model, right? So in the main thing, what do we need to do? We want to also have GLUint uniform model. After we've created the shader, we want to do uniform model equals shader1 dot get shader1 dot get uniform model, and down here is where we draw. So we want GLM map for the matrix, which we're going to make. Oh, that's what I've done wrong. I don't think there's a matrix in this bit. It's a vector. So in the vert, we want that to be a map for, because when you times a matrix by a vertex, it works. That's my explanation. Hope you enjoy that. Great one. Right, map for model equals 1.0f. That just initializes every single value in the matrix to 1. Sorry, there we go. And then we want to do this weird thing. So GL uniform for FV, I believe, and then we want model. Why doesn't it like it? Probably because I've messed up a capital. Yeah. We want the model, the count. I'm just going to guess that's 1, and then the value, which is actually something we need to do up here. We need to include GLM / GL value pointer is called. Is it GTC value pointer? Maybe it's GTX. Why can't I find it? Must be GTC. I thought it was called value pointer. Type pointer, maybe. Maybe it is type pointer. And then here we want GLM value pointer, yeah, and then model, and that's passing in. This is uniform model, and that's passing in the values of the matrix that we just made to the uniform model, so it knows not to times by. So if we were to have something like GLFW time now, yeah, time maybe, yeah. So I'll make a quick thing. So what should we do? Let's call right. So GL float time equals get time now. Actually, rather than do it that way, let's do sign. And then we want to translate GLM translate model, and we want the vec3 of x, y, and z. So we'll do nothing to on x. We'll do the time thing, and we'll do 0, 0. So what that's doing is times in translate. I thought that was translate. So yeah. Oh, there we go. So the time thing that we got here is times in glfw get time by sign. So it's just basically like when you times anything by sign, it will just go up and down between 1 and -1, in like a yo-yo pattern like that. So this should be, if this works, basically it will just have the triangle that we had originally just kind of going up and down. I don't even know if this is going to work. I'm just kind of playing about at this point. We haven't got even let the thing draw in. Why not? Uniform map for model times vector. Let's see what happens when we just have vector 4 in there. Yeah, so that was working. Model times, and then in this bit we're passing in the variable. Oh, I think it's because we're not using the shader in the loop. So we want it before the draw function, probably after we've updated the model stuff. See what happens now. Nothing. Let's have a look at the information. So we want location, count, and value. Well, if we were to put this as like -1. Nothing. This is strange, this is. Just doesn't like the model. So we create a shader, get uniform model. Maybe that needs to be in the loop as well before. Oh, actually we can put it up the top. Nope. I am so lost. Tell you what, let's have a look at my other projects. That's what we normally do when I come into a problem. It's cheating, really. Shader. It's not going to be the shader. I don't think I'm even using shader in this one. I've got a shader bit made. Creating a shader, not using it. Damn it. Let's look at one of the other ones on 2017 then. So this will be in version 3.3. No, I probably shouldn't have loaded up this one. Oh well. I'm sure it's something to do with the. Where's the model? That's what I'm doing wrong. I didn't put the matrix part in there. Apologies. So GL uniform matrix 4FV. I don't think that's supposed to be that bit. What? Oh, I shouldn't have deleted. Right. GL uniform matrix 4FV. It's not liking the pointer. Incompatible. Location count. Oh, I didn't put the transpose part in it. So GL false because we're not transposing. Hey, we got the triangle. It's not moving though. Fine. There we go. We got a moving triangle just using shaders. Magic. Looks kind of funny. Yeah. So apologies for that being longer than I expected, but you can see the kind of the fun that you can be had. So in the next video, I'll probably do model times. Or actually, I think it's something like projection times model to get it correct, and we'll have it rendering in 3D. So we'll just add some stuff to the vertices, add some stuff to the indices. You see how easy that is as well, because the way we've set up this function, we can just expand this, and we can also make multiple objects as well, which is quite cool. And also with the uniform variables, I'll show you some other fun stuff. Just quickly before we go though, I wanted to try something else that I thought of when I was looking at this, which is we want a vertex color. So in the shader, we want out vec3 vertex color. I think they've got it as vec4, but I'm going to have it as vec3, and then we'll just transform it in the shader. So here in here we've got in vec3 vertex color, in this, and then back into the vertex shader, we'll make the vertex color equal to position, and then the frag color, we'll just comment this one out. Frag color equals vertex color. Oh, that's a vec4, and we'll go like this, 1.0f. What this thing is doing, because it's, I know you guys might be looking at it strange, where this is a vector 3 and this is a vector 4, we've got 3 values in the vertex color, so we can just pass in the vertex color and then just add one on the end. Okay, now what I've just realized is these are going to be between 0 and minus 0.5 and 1, so I don't even know what happens when you go into negative color, but we're about to find out. There we go. Just goes black by the looks of it. That's the negative one. Yeah. We could always times those values by sine as well, if we were to be clever about it. Anyway, yeah, fun stuff. We'll do more in the next videos.